Right, this is a continuation tutorial where, so the YouTube video ended at this point, but some students want me to go back, and so this is a good opportunity for me to show you a feature that Fusion has. So we've saved this. It's been a couple days since we've opened up this task here, and the Fusion. One good thing about Fusion is we have down here we have the timeline. Right? And the timeline is every action we've taken in this drawing. And what this means is if you want to go back and change the timeline, we can. And some things are as simple as if we want to go back and change, an individual sketch, we can right click and we can edit that sketch and we can change that particular sketch. And then what it will do is redo all the other commands based on that change of the sketch that you wanted. So I'll do something ridiculous, for example. Let's say I want to move this. Can I move this dot? Can I move something? What if I modify? Can I move this particular part over here? No. I can't make it simple. But if you move a particular part, you can change it, especially if you have a dimension, and it will redo the whole rest of the drawing. It also means if you want to go back, you can drag this thing all the way back here, and then you can start making changes. Now, if you make any changes from this point, like if you do a new command, it's going to delete everything in front of it. So that's the options. You can either go back and right click and edit something. You can edit it and then it doesn't ruin everything else, unless that part is like dependent on something else, which could potentially happen. But if we bring that needle back here, if we bring that needle back over here, we're at this stage, and this is where some of my students are. So I'm just going to refresh what's happening here because I kind of sped through that at the end, the last one. We need to make a diagonal line connecting these two poles together. So we're going to be making a new plane, and I'm going to be using this feature a lot today. So kind of good that I get to show this. We want to make a new plane to show we're going to be doing our drawing. So we're going to go to the construct tool, and we're going to do make a plane along 3 points. So now if you remember in maths, or if you think about it, if you have any 3 points in space, you can make a flat piece of paper, a flat surface based on those 3 points, no matter where they are. And that's what we're doing here. We're picking 3 points, and then we're making a flat surface that goes through those 3 points. The 3 points we're going to pick is, if we pick this point over here, and one of the corresponding points at the top here, we're going to cut basically our 2 pieces in half. So we'll do that now. We select our 3 points, because obviously here we can select our 3 points. We're going to select this point over here, select that point, and then we select that point as point number 2, and we select this point over here. And now that plane is the plane we want. And if we move, we can kind of see do you see how that's like in the middle of our 2 pieces of wood? All right? It's in the middle there. And then we'll press OK. Now, the reason we did this, and I don't know, do these delete? I haven't actually used this feature. So I think we can we'll delete all our other things that so we don't have to do them again. Delete and delete. So now we've done that plane. Now we're going to sketch. So we'll go to sketch. We can sketch that new plane that we made because it's diagonal. Wouldn't work with any of the other planes because the other planes are not diagonal for us. And we want this diagonal shape. So we'll click this. It's aligned up. We want to make a piece connecting these two together. Now, when I did it previously, I just got a line connecting this point over here to this point over here. And then this point over here to this point over here. Now, the problem here is, I'll show you, and we'll see how that looks. If I go to join, well, firstly, I can't actually connect to that because this object doesn't exist in the plane that we made. So we have to use our projection tool. We have to project and include, project, and we want to project this surface and this surface and this surface and this surface. So we're saying, hey, I want these features to be in my plane, and I press OK. And now we have these red dots over here. So these purple dots. And let's draw our shape. So I want it from this line to this line, this line to this line. And if this is correct, this should go dark blue now. There we go, which means it's a closed surface, so we can make that. Smart time. What's wrong with this shape? It is a parallel shape. It is a parallelogram. That's also, yeah, that is true. Um, I'll give you a hint. Yeah, exactly. Yes, you were saying it's not exactly 5. But the hint I was about to give is old mate Pythagoras would be kind of upset if we thought this was 5 millimeters. Our piece of balsa woods are 5 millimeters. In fact, we can check here. We can press this inspect tool and we say, tell me the difference between this line and this line. And that distance is 5.8. So it's thicker. It's not going to give us the correct values we need. So what we'll do here is we will say, okay, all right, we can make a line that is that thickness. We'll do the center line. The center line, okay, yep. And then we want to do a line that is 5 millimeters off there. So we'll press the offset button and we click this line, and 2.5 is offset in that direction. And then we press OK. And then we'll do the same another one. We'll do offset this one, 2.5, but we want it to be in the other direction. And then we'll press OK. And now all we have to do is, can we drag this out? Yeah, we just got to drag it out so it crosses that line over there. And then we'll do the same thing with this side over here. Want to cross that line over there. And then we have those shapes that we want. And then we can finish this sketch and we can extrude. And we want to press that shape to that shape. And now this is 5 millimeters apart. And now I know it's slightly larger. And look, when I look at your design, I'm not going to tell that difference, right? But where it matters is we're going to eventually get the entire volume of our tower to help us approximate how much material we're using. And what was the number? It was like 5.8, which is about 20% extra material we're using. And once we start getting a lot of these diagonal members, if we keep making that mistake, we're going to be getting a wrong number. So where possible, we'll try to keep it as close as we can to the number we need. So this over here is going from the center. So if we were to say extrude it as 5, I mean, that would work, but that's not ideal, is it? That's clearly too much to one side when we extrude it, because remember our plane that we did was in the middle. So where we have 5 millimeter distance, instead of it being in one side, we'll make it symmetric. So it's going to both sides. And instead of it being 5 millimeters, 2.5. And so that's now our piece of balsa wood there, connecting our tower together. So far, so good. Now, we have these 3 shapes. I'm going to pause the video here. All right, before I move on to the next step, let's assume, right, you're one of my students that is very far behind, right? What are the chances of that happening, right? All right. So there's actually a way we can do it really fast, but the faster we do it, the more mistakes that are going to happen, right? Or not the more mistakes, the more inaccurate we're going to be. So another way we can do it, again, let's just do a sketch on the side. Now, if we look at this tower over here, and if we look at it from this particular view, right, this tower has a particular shape, right? Up, angle, up. And we know the height for that is, we know the height, so like the 10 mil and 8, something, 10 centimeters, 8 centimeters. And we know our rough dimension inwards based on the diagonal length of the box, because we want to hit the corners of the box, right? And I think I remember there was 150 at the bottom and it was 75 on the top. So what we can do, we'll go to this sketch over here. We can go to our sketching tool and we'll say, okay, so we'll make a line over here. And this over here will be 150 divided by 2. And then we've got to find out if we're going to do Pythagoras, old mate, over here. I'm going to do, so what is it? 150 divided by 2. And we want to times this by cos 45. Or sine 45, either way. 75. Oh, that's nice. Is it just half? No, can't be, is it? Maybe. So we have that length, and then we know our height. Our height is 130. Oh, wrong one. Sorry, our height is 300. 300 over here. And then this shape over here, we said this one was going to be, this shape is going to be 75. So it's sine cos 45 times 75. So 75 divided by 2. How are they the same number? That can't be right. Oh, yeah, it's cos 45 times 75 divided by 2. Is that not working? Or do I have to do it manually? 75 divided by 2. Ah, okay, I have to put the cos in a bracket. So over here, should have known my maths better. This was 150 divided by 2 times cos 45. Ah, that's better. Okay, these are our two shapes. And then we know we're going to have a line that goes down here. This line's going to go down 80. And this line is going to go up. This line's going to go up 100. And then we're going to do this line just connects these two together. All right, and that's basically the shape of the side of our tower, right? Up, diagonal, up. One thing we do have to change here is what my goal here is I'm going to try to draw a line that's going to be the middle, like a spine of my pieces of balsa wood, which means I've got to like offset it slightly because we know our balsa wood has a thickness. So instead of that number just being this number over here, we just want to get this number and say plus 5 to make it slightly larger. And we want this number to be minus 5. Minus 5. There you go. And that's the shape we want our tower to follow. And we'll just press finish sketch. And then we will go to our sketching tool and we want to sketch. The next thing we want to do is we want to sketch down here. And we want to say, all right, where this dot is, we want to make a square where this dot is. So we want to go to rectangle, center. Do we attach to that? We can't attach to it because we haven't projected it yet. Project and include, we want this geometry. Okay. And if we go press this square, and this we want it to be 5 tab 5. Cool. So the fast way to do this, which is the less efficient way, which is the less accurate way, but once you have that diagonal line, we're then going to use the sweeping tool. We want to sweep this along. Ooh, along that path. Which isn't great because that's the whole tower. So instead of doing the whole tower, we want to change this arrow over here. Which one do we want? There we go. And that is... I'm sorry, what happened there? We lost something. Okay, sorry. I had something that went here. Edit feature. Maybe I did the wrong direction. Profile is this profile over here. Yep. The path I want is... Let's start again. The profile I want is this profile over here. The path I want is... I want to turn off chain selection. And I want to select this line. I want to press that line, and I want to press this line. So the problem is I had to stop pressing the chain selection. Let me pick the individual lines. But now I have 1, 2, 3, and I press OK, and we're roughly in the same state. We have this line over here, which is very similar to this one over here that we made. Except this one is the more accurate one, because this one has weirder shapes to it. But hey, it's a fast way to do it if you need to catch up or you want to rapidly change your design, because you might change multiple designs as you're doing it for your testing. But you have this shape. Then this is not your tower, right? This is only one side. So we're going to use the next tool. We're going to use the pattern tool, and we're going to use the circular pattern. We're going to press the object, which is this piece over here, and the axis we want to revolve it around will be this center axis. And if we change it to 4, boom, that's our tower. That's our 4 lengths of our tower. So then, what do you think is the next steps? What's the next thing we need to get our tower done? Yeah, we need the horizontal pieces, because remember we're learning our buckling equations. We want those horizontal supports. To do our horizontal supports, we can, I like to do it this way, if you want a simple way to do it. Because we had these flat surfaces over here, we can select this flat surface, and we can then just make our little triangles. Sorry, I say triangles, I mean squares, sorry. Our 5 by 5 squares, and then if we finish this sketch and we look in the 3D, we see those, they're there, and then we can press extrude, and we can press that shape and that shape, and we want to pull them out. In Fusion, you can either pull them out, you can either write the distance manually, or if you actually say where you want it to go to, when it comes to distance, right? When you're typing the distance, instead of actually typing the number, if you press the surface you want it to touch, it will also do that as well. And the line goes all the way to there, because you press that surface you want the thing to touch. So we've got that. And we'll do the same with the top as well. So if you want to see me do it again, we're going to sketch. We're going to sketch this plane over here. And because I sketched and I pressed that flat part on the body, it automatically includes that body in our thing. So I didn't have to do the project or include. If you didn't press the body and you press like a plane, you would have to do the project and include function. So here, 5 by 5. 5 by 5. Finish sketch. We want to extrude that. We want to extrude this. And how far do we want it to go? We want it to hit the other. We want it to hit the other wall. So under distance. Yep. We want it to go to here. And then press OK. Cool. The next thing is we need something diagonal to support this wall, because we want it to be a triangle. So we'll go over here. We'll sketch over here to make something that looks to make sense over here. How I will do it is I'll just press from this corner to this corner. And then we just want to offset it at 2.5. And actually, if we press this over here, instead of doing it twice, we can just say symmetric. It's going to do 2.5 in both directions. That makes it a lot easier for us, actually. And then when we finish our sketch, we can extrude this. And like the other one, we want to make it 5 millimeters thick. And we just want to make sure that we do it 5 millimeters in the correct direction. So see how it's, if we type 5, it's going to go that way, which we don't want. So we just want to make it -5 because we want it to go inwards. And the same thing with the bottom one. And then we only have one more difficult one to do, and then we can start testing our tower. So we have one more easy one. And this one over here. So again, we press that flat surface that we made. We'll go corner to corner. corner to corner, offset it, 2.5, 2.5, symmetrical, okay. And then we will finish that sketch, extrude, -5, cool. Now this is the difficult one, this diagonal member over here, because we don't have an easy plane to make this one, right? Because there's nothing flat. So we're going to use the same tool we used previously to make the plane of 3 points. And so we're going to select those 3 points. These 3 points we're going to select are this corner, and this corner over here. So if this makes sense, if we're going to look at it, maybe when I rotate it, you'll understand what it is. Do you see that plane? Does that make sense? So that's what we're going to do our drawing of to then push it into our tower. So we'll sketch that. Sketch that plane over there. Now we will need to include the geometry in this. Project include. We need to do this shape and this shape. Okay. And then we can just do our line like we did previously. Now this one is not going to be as clean as our other line. So what we'll do, actually no, I made a mistake. We don't do a diagonal line from there. Sorry. We want a line to be 5 millimeters thick. How do we do a line that's 5 millimeters thick? That's correct. I don't even know what that angle is. We'll try it this way. Sorry, we'll do the diagonal line. I was trying to think of an easy way to do it. We've got a diagonal line going there to there. And for this one, there's no real easy way to do it from memory. So we're just going to do offset in 2.5 in both directions, symmetric. Now here, is that blue on the inside? Is this blue? Come on, yes or no? No. What does that mean? What does a not blue thing mean? Because it's no. It's say it again. Louder. It's open. Yes, it's not closed. More specifically, yes, it's open. The other ones automatically were closed because they had that other geometry to use, right? This one, if we actually zoom in here, they're not actually connected here. So what we're going to do is we need to connect them together. If we go to here, and notice the thing on Fusion, see how this has white dots over here? So white dots means this is like the end of a line. There's nothing connecting it. But as we close here, now let's look on the inside. Let's see what happens. This one is actually blue. This one is not blue because this one has this geometry over here that's closing it. So I'm showing it on my board. This one over here is closing it. If we go here, now that's blue. Finish sketch. We will then extrude this. And now when we extrude it, we got to make sure that we select everything. Because as we select this and this, see how we're missing this part up here? This part's not selected. So I hold down the mouse and make sure that blue part is selected over there. And I think the same at the bottom, down here. Yep, this isn't selected, so I select that now. So now it's all done. We'll then make it 5 millimeters, but I believe it's going to be -5. But I'll just confirm. No, we don't want to cut. We want to join. Oh, it is in the right direction. Good. Lucky we checked. Okay. So that's that part of there. Cool. Done. Is this complete? What's missing now? Yeah, all four sides. So we already did a rectangular pattern before, right? You can do it again. And when you do it, it doesn't matter if they overlap. They'll just smush everything together. So we'll do the same thing. Pattern, not mirror tool. Pattern, circular pattern. This whole shape over here. The axis is this axis over there. Make it 4. Press enter. Wunderbar. There we go. There is our tower. Done. So now, how long do we have? 15 minutes. Cool. We're going to save it here. Now we've saved it, I'm going to rush through and show you what a simulation looks like so I can hopefully get one done in time to show you as a class. So you have to save your design. It has a name. Lovely. Now if we go to design and we go to simulation, because we want to see based on here, I'll run the simulation and then I'll show you some other features we can do while the simulation is running. We just want to do a static stress because we just want to find out which members are experiencing the most stress. Create study. Oh, we have these two boxes over here. We don't want these, so we need to simplify. In our simplification, we need to hide these two things. So what we're going to do here, we can right-click and we can say, which is the best option? We can just remove, and we can right-click this and we can press remove because we don't want these two things affecting our simulation. We press OK. Then to do our simulation, we need to do our contact points. Now this is a bit weirder because this is more advanced in our classic truss analysis, but we want the bottom of our tower to be fixed. So we'll press this whole bottom surface. Is this all one body? Let's need to check. Oh, no, hold on. We have to change this. Before we do this simulation, we have to make sure this is only one body. So once you're finished, once you have this all together, over here there are multiple bodies that are overlapping together. So what we want to do, and make sure our boxes are hidden, our top and bottom, we want to highlight everything and we want to combine together and press OK. And so you want that all to be just one body. So now that's one thing is the whole thing connected together. Save, design, simulation. I believe it's still, they're still gone. We will then go to our constraints. We want the bottom of our tower to be fixed to the ground. And notice how it has a padlock there. So that padlock says this surface over here, this surface is not going to move in our simulation. Okay. Then we want to put a force on the top. So then we're going to go to loads, structural load, force. And we're going to press this over here. We want this whole surface to be on a structural force. And then we want to say, just give it a number, 100 newtons. The number actually doesn't matter because, I'll show you why later. But over here, so you have a force pushing down a tower. But actually, instead of a force, I may as well show you the proper way. Let me go back. We don't want that load over here. Force, right click, edit the structural load. Instead of a force, when I described how the tower got tested, do you remember how we're actually testing the tower? What is it actually doing to our tower? It's not providing a force to our tower. We had that rod, and what's the rod doing to our tower? Yeah, it's squishing our tower. So we can actually tell it. We can say, oh, actually, we can actually put a, not a force. I think it's, delete this. I think it's this constructional constraint. We can actually put a prescribed displacement. So this part of the tower, I want to say I want to move this tower down in the minus 15 millimeters. So squish the tower down 15 millimeters and then tell me what our forces will look like. We should check if there's any parts here. No contacts. Wonderful. I think we're ready to solve this. Solve. Solve. Solve study. All right. So now this is solving. It's uploading to the system. And while this is solving, I'll show you what else we can do with our work. So let's go back to the design. Now, I don't want to change anything here, but I can still inspect my tower. We can inspect it. The purpose we did this is, well, we can do some things like we can measure. I can say, well, how long does this piece of balsa wood over here have to be? Well, I can measure it. I can measure the length. I can measure from like this point to this point. Oh, that point to that point is 113. So I know I'm going to have to cut my piece of balsa wood 113, but actually I'm going to have to do it slightly more than 113 because if we look here, that's not a flat edge, it's angled. So I know I'm going to have to make it slightly more than 113. The other thing we can do is if I right click this body and I say properties, we have some information about the property, the thing. Now, firstly, it's steel. Our balsa wood tower, is our balsa wood tower made out of steel? What is our balsa wood tower made out of? Oh, wonderful. Yes. Unfortunately, balsa wood isn't in Fusion. Well, maybe, but it's not useful for us because it needs to be a homogeneous, everything correct in the one direction. And wood is not homogeneous. It changes its strength values if you're going with the grain or against the grain. So the weight value isn't correct. Your tower is not going to weigh 900 grams. Your tower is going to weigh like 30 grams. Your density is also not going to be the same. Your area doesn't really matter either. But what does matter here is the volume of the tower should be the same as your tower. Given there's going to be some margin of error because like some pieces have merged into each other, but that's a good close approximation. So that's the volume of all that material. You know your balsa wood rods. You know you can calculate the volume of all your balsa wood rods because you know the length of them. They're like 905 millimeters, or the design requirement specifically said 900 millimeters, and you know its length times breadth is 5 by 5 millimeters, and you have 8 rods, so you can find out the volume of balsa wood you have. So when you in your assessment task you have to prove that your design could be made out of balsa wood, you calculate what your volume of balsa wood you have available is and you compare it to this design over here. I would say because some things you're going to need extra for example, this one here in the corner, yours obviously going to have to cut your balsa wood at an angle to make that piece, right? But over here, it's assumed you did like a perfect cut. That grammage you wasted there, you're using somewhere else. So maybe add like a 3 to 5% buffer to account for you cutting your materials together. But that's a good approximation. You can find out how much volume of balsa wood you have and you do this design. Because what we'll do is as we start to get our simulations, we'll see the areas that are under the most stress. And that's where you should maybe put more material for the extra balsa wood you have. So you can do multiple designs. And then you can do some really spicy designs. Which is the ones that, these are some that I've been working on. So I've been working on like this design over here is the one I'm currently working on. Right. What's another one? The concept tower. This one over here. Now this one, I don't know if this one works or not. I haven't actually tested this one, but here's another one. Yeah, go. So over here, it has the thing, the rod can fit in the middle, and I want it to have like these, and this is like double thickness as well. Some students even do half thickness of their rods. They cut their rod in half. You ever really remember that the strength doesn't matter as much? You can even cut a rod in half to get double the length of rods if you want some specific applications. But I can test all these. All right, so we're back in here. Let's see if our simulation is done. Is our simulation done? Let's look at our results. Do we have any results? Fetching our results. Remember, if you have your student account, you get unlimited of these. You don't have to pay for them. They just take time because they have to make your model, send it to their server in Seattle. And oh, look at that. Oof. Now, the first thing you have here, and they send the model and it comes back to you, right? In fact, most of the time, because our models are relatively simple, most of the time is just actually sending the file and getting it back. All right, so factor of safety, that doesn't really help us because factor of safety Doesn't matter because that's related to like steel. But what we want instead is instead of factor of safety, we want no, we don't want factor of safety. We want results. We want stress. Sure, von Mises, whatever. So here is our tower, and we can find here where our tower is experiencing the most stress. Now, this is just relative because, again, this is steel. So the actual value of the stress isn't useful to us, but we can relatively see because we know all our material is the same material. We can see relatively where the most stress is. So the darker the color, well, the redder the colors, the more stress. So based on this image, where does it look like the most stress in our tower is? Which ones? Yeah, like these ones over here. And what we can do is we can actually press this scale up here. We can drag it up and remove the ones that don't matter. So here, those are the ones that, yeah, they're fine. They're chilling, right? They're no issue at all. But then we can look at the other parts and see where, a lot of the stress is here on these corners. And if we actually bring it up, specifically, it's like over here, there's going to be some sort of buckling happening over here. So this diagonal member is the one that's experiencing the most stress. And you remember when we did our explaining how failure will happen? If this is under compression, I don't think I can show it on here, can I? But we know it's under compression because we can do some basic truss analysis. If this is under compression, it's going to fail under buckling. So we have to, this is where we're likely to fail under our buckling. So we can do things. What are some ways that we can reduce our failure under buckling? We can make it thicker. Yeah. Oh, we can add another. Yeah. We can add another member here, diagonal, another horizontal member to reduce that length. Again, we're using more material if we do that, or we can like double the thickness. We can change our I value as well. We can put two pieces of balsa wood on top of each other if it fits in our design. But that's where the most stress is, so that's where it's worth putting it. It's if a student came to me and said, I'm going to put extra balsa wood for this diagonal member over here, right? Would that be a good idea? If they did this member over here, why? Justify. Why would that be a bad idea for them to put extra balsa wood there? Yeah, it's experiencing less stress than other parts. So sure, you could do it, but there's better places where you can do it. So that's what the Fusion simulation tells us. Now you might change your design. If you put that horizontal member, what should you do then? You test it again. You make that design. Now I wouldn't edit the design per se, because then you can't look at your original design and it's going to affect everything. So if you want to edit the design, I would go here and I would go to File and I would Save As and make a new version. So if I want to do that, I'll press Save As. And then over here, and I can say Part 1, that's the name of this tutorial, but I can say version 2. So then I can edit version 2 and I can see what my relative stress is between my version 1 and version 2. All right, that is it for this tutorial. I'm about to save and then I'll upload it later.